Let's do a few more examples of how we would evaluate some functions. So let's start off with maybe something like this. G of x is equal to 2x minus 5. Now notice here I wrote g of x instead of f of x. It doesn't matter, it's very arbitrary which letter we use. We tend to use f a lot because f stands for function. But we might use g, we might use h. Those are also common ones, especially when we start talking about more than one function. You don't want them to have the same name, so that you can pick what letter you want to use. Coincidentally, you can also pick which variable you want to use. So I'll do a few other problems that have a different variable in it. Again, the variable is just a placeholder. It's very arbitrary. We tend to use x a lot, but you don't have to use that particular value. So something like this, I might give you g of x and then ask you to evaluate, for example, what is g of 2. Well, g of 2, you just take x equals 2 and plug it in everywhere in the function. So replace whatever is right here with whatever you put right here in the parentheses. So this would just be 2 times 2 minus 5. So 4 minus 5 is equal to negative 1. So we would say that g of 2 is equal to negative 1. What about something like g of x plus 5? Well, again, this isn't a number, but this is an expression. It doesn't matter. We still do the problem the exact same way. Go into the function, and every time you see an x value, replace it with whatever this expression is here. So instead of 2x minus 5, it will be 2 times x plus 5. Replace the x with whatever's in there. We don't care what it is. It can be incredibly complicated or something really simple. And then just put that into the function. And then from here, we would want to simplify. So from here, I would say 2 times x plus 2 times 5, so 2x plus 10. And then minus 5, so this should be 2x plus 5 is g of that expression. G of x plus 5 is 2x plus 5. Now I can also do something like this. G of, we already did 2, let's do the 4. G of 3 minus g of 1. In this case, I need to evaluate g of 3 and then evaluate g of 1 and then subtract them from each other. So the order here is you want to take care of this first, and take care of this before you do the subtraction. So for example, g of 3 would be equal to 2 times 3 minus 5, so 6 minus 5, which is 1. But g of 1 is going to be equal to 2 times 1 minus 5, which is negative 3. So g of 3 minus g of 1, that would be 1 minus negative 3. So we get a positive 4 for that one. So those are a little tricky just in the fact that you have to do a little work before you actually put the two together. So how about another example? We could do f of z. Again, I can make my letters arbitrary. In this case, z is going to be the variable, and f is the name of the function. F of z is equal to z over z plus 2. Now in this case, I have 2 variables in the function, but that's fine. We still follow the exact same rule. So now, for example, if I say, what is f of 0? We just go through the function, and everywhere we see a z, we're just going to replace it with 0. So this would be 0 over 0 plus 2. So this will be 0 over 2, which is just 0. Or something like this, f of negative 1. Again, just go through every time I see a z, I'll replace it with a negative 1. So negative 1 over negative 1 plus 2, and then simplify. So negative 1 over positive 1. So that's a negative 1. Or I could put in an expression again. So how about f of x plus 3? Now remember, x is not a variable, we don't care. This just says take whatever is in the parentheses and replace the z with that every time you see it. So now instead of putting z over z plus 2, for that top z, I'm just going to replace it with x plus 3. And for that bottom z, I'm going to replace it with x plus 2 also. And then add the 2 to it. So again, don't overthink these problems. If I give you something that looks kind of funny like that, f of x plus 3, just replace that in the function and then solve from there. So this will be x plus 3 over x plus 5 after you simplify that down. Again, I can do something like this. F of 1 times f of 2. Again, figure out what f of 1 is and f of 2 are first. What f of 1 and f of 2 are first, and then multiply them together. So f of 1, for example, would be, we need to go back to the original problem, so be careful with that. I'll go back into that one. This would be 1 over 1 plus 2. So 1 over 3. And then f of 2, this would be 2 over 2 plus 2. So this will be 2 over 4, or 1/2. So if I want to take f of 1 times f of 2, this would be 1/3, which is f of 1, times 1/2, which we decided was the function of 2. This is the way you do all these problems. There's not really much I can do to throw you off, to trip you up, except for maybe putting in something like this. It can get a little tricky then. But even then, you're just plugging in, and you're not having to think a different way about these problems. You always think the same way about them.